Let's take a look at how Inventor, and I'm going to be using a sheet metal part, kind of makes things kind of cool that you can use parametrics. So let me come here and just say, I'm going to make a box. So I don't know exactly how big the box is. So I'm going to pretend that it's going to be 8 inches. And I use the tab button 8. And then I can make that thing into a face. And for now, I'm just going to let it be. I don't need to do anything fancy with it. And so there I've got sorry, I'm not doing a good job with my mouse today. There I've got a little piece of a plate. And the cool thing about Inventor is that if I look at the parametrics of that, the parameters, it lets me know, and I can say, oh, what is that? And that's box bottom. And if I know that it wants to be square, I can just say that this one equals D0. So no matter what I do to that, there it is at 8 by 8. I'm going to move it over here. And look, because I'm doing it parametrically, if I change that to a 4, it gets smaller. If I change it to a 12, it gets bigger. So this is why in Inventor, if you have sort of the idea of the shapes, you can get the sizes right later on. Now there's another thing that says, regardless of what size this is, I can put a flange on that. So let me put a flange on that one, and I'll make that one, let me make that one 8 inches long too. So I'm going to have an 8 by 8 box. So that one's okay. That one's okay. And that one's okay. So now I have an 8 by 8 box, and I have a little opening. And that's one part. But maybe I need something to attach the top on with. So I'll just put a little lip sticking out the top of these two sides. You can do it kind of however you might like. There I go. I've got a box. And again, if I look at the parameters, I can say what all those are. This is my side. So there's my flange 1, and there's all sorts of stuff that goes into flange 1. So this one for flange 2, I want to make that one. Oh, that's my sketch 1, 8, 8. So now I don't know what that one is. So this one, I'm going to make that one equal D0. This one equal D0. Everywhere I'm seeing an 8, I'm making it D0. There we go. And so again, now if I change this 1 up here, way up here to a 4, everything goes away. Oh, I didn't get them all, obviously. I have a couple of them that are, oh, there's one right there. D0. And I'm missing another one. D0. There we go. And then if I make this one 6, it changes. So that's part of parameters and constraints. And it's a very cool tool. So I have the idea of box, but I don't know the size yet. But I do know that all of these sides are going to be the same. Or maybe these will be half as tall as they are wide. It's up to you and your design. I'm just doing an example for you. Okay. So there we go. That's kind of there. And then my other part, maybe if I'm going to make a box, I could make this one come up also. But often what you'll see is a 3-sided box because it's easier to weld and easier to bend. And then maybe I'll put another lid on. I just wanted to show you how Inventor, you can start with a box and then have the box idea. And then in Inventor, you just do some things. Now, here's the really cool part. I'm going to make this down here, and it doesn't matter what I pick, my A size. And now I can pretend that that's cut out of one piece of metal and bent up into shape. And Inventor will give me all that. Now, this is not to say that this is how you need to do this. You could do one that's 3D printed style instead. Let me look at doing this as if it was a 3D printed part. So this is a sheet metal bent part. Let me start a new standard part now. And I can see that maybe I want to do a box, and all the same tricks apply of parametrics. So I'll start with 8 by 8. And again, I can look at the parameters and say that one is the same as D0. That's my D0. That's how I know what it is. Okay, and let me extrude it up 8. Now, that's exactly how SketchUp works, right? You draw a rectangle, and then you make an extrusion. Okay, and if I want it to be a perfectly cubic box, I'd say that one's D0 also. Now there's a cool thing. I can make a shell out of this. I'm going to shell, and I'm going to remove this top face. And see how, isn't that cool? And I'll make it like 3/8 of an inch thick. And there I've got a cool box. And I can 3D print this. This is a very 3D printable part. Okay. And you know, sometimes when you make things, you don't want sharp corners. You can do all sorts of cool stuff with making the corners not so sharp with a fillet. So Inventor is a very cool tool for this kind of work. I can even make the outside kind of rounded just a little bit. And if I wanted, even in the bottom corners, sometimes it's just nice not to have sharp corners. There we go. There we go. I have a really nice looking part there. So that's, and again, they're all parameters, right? Okay, and maybe this would be, maybe I want it D0 divided by 16. Maybe that's, and that came out to be 0.5. Maybe you always know that I want it 1/16 of whatever that size is for some engineering reason. Look, I can change all those fillets to 0.25 if I want to, very quickly and easily from these parameters. So as you work with Inventor, you'll see that it's maybe not quite so easy to model in, but if you're thinking it through ahead of time, this is why you're going to want hand sketches and kind of think about it a little bit and sort of make some of these ideas that I want it to be a cube. I want it to be, maybe you want it to meet the golden ratio. Maybe you want it to be rectangular to match a brick or something like that. You can think about those things and you can just assign them over here. You just draw something and then you assign the real values. So that's concept visuals. Now, and that's just still a concept visual. There's no dimensions on it, no anything else. I can put it into different views, styles. I can make it technical looking. I can do the sketch style, watercolor style. So the same types of things that you could do. in SketchUp. Maybe not quite as much, but I can do materials again. So if you want it to look like it's copper, upload that into my thing. And so now I can put materials on just like in SketchUp. It's like SketchUp, but it's more powerful and more usable on the mechanical level. And it's very easy for me to make dimension drawings later on, which we're not going to do, by the way. We're not going to create dimension drawings. We will create flat outputs. So there's two ways that I could make a box. I could make it out of sheet metal. I could make it out of something like this. What you need to know, though, is that when you make a single part in Inventor, you are making a single part. Assemblies are made in a different manner. In Inventor, you make the parts first, and then you make the assembly. In SketchUp, you can kind of play both ways, and same with AutoCAD. But I have to make each individual part. So if I wanted to make a lid for this, I would need to make another part called lid. And I'd have to know some of these dimensions. Well, I'd make it the right shape, and then I would measure some of these things and go change them in my parameters. So hopefully that gives you a little bit of information about parametrics, sheet metal parts, and maybe if you wanted to 3D print it. If you wanted to, you could make this out of a solid chunk of metal and use a mill to mill it out. There are many ways that you could think of making this, by the way. I could get a piece of square tubing and weld a piece into the bottom. I could make it out of wood, and I could laser cut all these parts and hook them together and glue them, or slide cut them together. So you'll be thinking about how you want to make yours and what materials you want to use. To make it at American River College, we can either make it out of sheet metal, we can make it out of flat pieces of wood or acrylic or cardboard, or we can 3D print it. Those are the three ways that we have the most access to. Okay? So there you go. That's your concept visuals with Inventor and parametrics, sheet metal parts, and 3D printed parts.